exponential expression, a to the power b, where a is the a is the base and b is the exponent. So if we have something that looks like this and we were asked to draw it, it would look something like this. Okay? So where x is your power, then it's going to be an exponential function. It's going to go up looking like that. It's either going to be a growth or decay function. So a growth one would look like that, and a decay one would look like that. A growth one would be where the number at value of a is bigger than 1. So remember, this sign here means absolute or modulus, so the size of it is greater than 1. And this is where the size is less than 1, so in other words, if it was a fraction. Okay, so if your base was a fraction, it would be a decay one. Going back up to this, how can, what did we even say here? How do we draw these? Well, obviously in paper 2 you'll have your calculators to help you. If you were ever unsure about what these things look like, you could just choose some values for x. So I've chosen -2, -1, 0, 1, 2, and 3. And then you just stick those values into the expression. So obviously this would be 2 to the power -2. Now we all know that our negative powers can be rewritten, can't they? We reminded ourselves about that last lesson. So that would be 1 over 2 squared, which is obviously 1 over 4 or 1/4. So similarly for all of these. Now you will notice that this one goes through 1, this one did, and this one did. Why is that? Anyone suggest why it might go through that point? But why will the y-intercept be 0, but be 1? What value do we know along the y-intercept for the y-intercept? What's this line also known as? Pardon? This line is also known as x equals 0. Remember, so the y-axis is also known as the line x equals 0, because we know that vertical lines always have an equation x equals a number, yes? So this line is also known as x equals 0. Well, we've just said that our power is x. So along this line here, our power is always going to be 0. Anything to the power 0 is 1. So that's why these graphs are all going through the coordinate 0, 1. Okay? All graphs of y equals x pass through the point 0, 1. You may want to write in here because when x is 0, the value of y will be 1, and everything to the power 0 is 1. Now note that's just for a graph in the format y equals a to the power x. As soon as you start having additional things, so for example y equals 3 multiplied by 2 to the power x, it's no longer going to be going through the value of 1. Okay, so it's only when we've just got a simple base and a power. Okay, equally if we have y equals 2 to the x plus 7, that's also not going to go through the 0.01. So just be aware that it is just for those basic graphs, and that's the reason why. Okay. What else have I got here on this little thing? Now E, have we ever heard of this value E before? CIE people may have done. No, you don't. I don't think so. Okay, E is a special number. Okay, E is called the Napier's constant. You don't need to learn the value of it. You don't need to know the name of it. You just need to know that it's a special number. And it is a special number in a similar way that pi is a special number. Okay? So pi, we don't ever need to necessarily remember the value of it. but we know it's constant. Okay, so it doesn't ever change. E doesn't ever change either. E is important when it comes to logs because exponentials and logs, because a lot of our real life situations are based using Rapiers constant. If you fancy doing a little bit of research about it, feel free. But anyway, heads up to you. And so E is a special one. So what's it say here? What's that? Yeah, anyway. So yes, just be aware that sometimes we have a base of E and it's a special number. Okay? Oh.
Long.
So I'm not sure.